Hello friends, myself Sanjay Singh from Government Engineering College Ajmer. Friends, today we will see, at the last lecture we have studied the serial communication between two devices as the microprocessor 8085 or any microprocessor or the processor is a parallel device and that generates the data in parallel form. For long distance transmission, that parallel data should be back converted to the serial form so that the number of wires can be minimized between long distance, and therefore the total costing for transmission of data will be reduced for a long distance. For that purpose, we have to convert the parallel data into serial and at the receiving end back the serial data into parallel. For transmission of data, there are three modes we have already studied, that there is a simplex mode, half duplex mode and full duplex mode. There is a interface device that named as Universal Synchronous Asynchronous Receiver Transmitter, that is UJART. The IC number 8051 is a interface or a controller for serial communication between two devices or microprocessor to any parallel device or a serial device. So today we will study the UJART, its block diagram, its mode of operation, its pin diagram, etc. So let's start with UJART. UJART is a module of is a full duplex serial input-output communication peripheral. Means UJART is a synchronous asynchronous receiver transmitter. Means this is a controller or the module that provides both the synchronous transmission of data as well as asynchronous transmission of data. It also transmits the data as well as it receives the data. There are two modules. One is transmitter section, another one is called receiver section, that we will cover in next few slides. It is packaged in 28 pins that we will see later in pin diagram of 8085 8051 UJART. It contains all the shift register, clock generator, data buffer needed for serial communication. It works in synchronous mode as well as asynchronous mode as already stated. The UJART uses two input-output pins to transmit and receive the serial data. Both the transmit and receive can occur at the same time, means it operates in full duplex mode. To send the data byte, an application writes the byte to the transmit buffer and the user then sends the data bit by bit in serial fashion in the requested format by adding the stop and start and parity bits as needed in the format of data. In the similar way, UJART store the receive byte in the receiver buffer, and the UJART can generate an interrupt to notify the processor to find out if data has arrived. Means there is a acknowledgement section is also there. Here is the block diagram of 8251 UJART. Here we see this is the section that is connected with microprocessor or any processor, and this is the section through which it connect with the uh, any serial input output device or a receiver or transmitter that is in serial form. So as we have seen in other peripheral interfaces, D0 to D7 is a data bus buffer, data bus that is connected with the D0 to D7 of microprocessor. This is the data bus that carries the data or that transmit the data from microprocessor to data bus buffer of 8251 and vice versa. This is the read-write logic that performs all the reading and writing operations, chip select signal, and these are the signals for modem control. And we will discuss these signals right after some slides. This is the transmitter section. That is, this is the transmit buffer that buffers the data that is to be transmit. This is the transmit control section that controls this serial transmission by transmit ready signal, transmit enable signal, and transmit control signal. These are the input and output signals that transmit ready and transmit enable signal are the output signal, and transmit control is the input signal that controls the transmission of serial data. This is the transmitter section. Same like this is the receiver section. In the receiver section, there is a signal that is called receive data, receive ready, receive control, or that SYNDAT means that controls the synchronization and baud rate of transmission. So mainly there are two sections. One is transmitter section and another one is receiver section that is connected with the serial input output devices, and this is the section that is connected with the microprocessor 8085. Here is the internal bus that connect all these uh, blocks or the control units of 8251 Usart. So let us see the one by one the sections of 8251. Here is the data buffer, read-write control logic, modem control, transmitter and receiver. So first of all, data bus buffer. This is the bidirectional 8-bit buffer used to interface the internal bus of 8251 with the microprocessor data bus. As we have already discussed, the direction of data transfer through the data bus is decided by the receiver or write signal. This buffer transfer control word, status word, or data to transfer means that through data bus we can send the data that is to be received or that is to be transferred. It can be used for sending of the control word or the status word of 8 to 5. Second part is read write control logic. It controls the operation of peripheral depending upon the operation initiated by the CPU. The control signals read, write, uh, clock, reset are given to the block to generate the control signals for the device. It includes the control logic, 6 input control signals and 3 buffer registers, two 8-bit data buffers, one for the transmitter and other one is for receiver. There is also a 16-bit word control register that names two separate register that is called mode word register and command word register. There is one more register that is called status register that is of 8-bit of size. Now the control logic that interface the chip with the microprocessor that determines the function of the chip according to the control word in the control register and monitors the data flow. Control register is a 16-bit register for the control word consists of two independent bytes that is called mode word and command word. Mode word that specifies the general characteristics of operations such as baud rate किस rate से data transmit हो रहा है, parity क्या है, for the error controlling number of bits means how many bits are transmitted per second, and the command word that enables the data transmission and the receiving of the data. Here is also a status register that checks the ready status of the peripheral, and the status word in the status register provides the information concerning with the register status and transmission of errors. There are some signals mm, that is used for input output port. When this signal is low, so when the combination is of chip select signal, control of data register or write signal or read signal, depending on this, microprocessor read the data from the data buffer when the combination is 0010. When the combination is 0001, microprocessor writes data to the data buffer. When the combination is 0101, microprocessor writes the data to the control register. and when the combination is 0101, then it writes the data from the status register, and when the chip selection signal is 1, and whatever the combination of control or data or read write logic, the chip is not selected for any operation. So now the third section of we have discussed two sections, that is data buffer and control logic. Now comes to the second end, that is called uh, the section that connected with input output in serial input output devices. It have two sections, transmitter section. So first we will cover the transmitter section. Transmitter section accept parallel data from the microprocessor and convert them into the serial data. It has two registers, that is buffer register that holds the 8 bits, output register that to convert the 8 bits into a stream of serial bits. Microprocessor writes a byte in the buffer register. Whenever the output register is empty, the content of buffer register are transferred to the output register. Here is the diagram that shows that how this transmitter section will be carried out. Here is the transmit buffer register, and here is the output register. When transmit buffer register, whenever the output buffer register is empty, it informs the transmit buffer to transmit the data, means the data it have is already transmitted. Now the new data can be sent to the this register. Transmit ready, here is the transmit ready signal that um, informs the external device that the transmit has been uh, the device has to be ready, and there is a signal that is called transmit empty that provides the signal that the data has been transmitted fully. And transmit control, that is the input signal that is used by peripheral devices. So whenever we want to transmit the character must be placed into the transmit buffer, which is to be shifted to output register. From here, it transmit the data bit by bit using transmit data pin. The transmitter section consists of three output and one input signal. That is, the three output signals are what? These are the transmit data, transmit ready, and transmit enable. And transmit control is the input signal. Whatever the functions of these signals as follows. Transmit data output, the output signal to transmit the data to the peripheral. Transmit clock input, this is the input signal that controls the rate of transmission, that what rate the data will be transmitted. And the transmit ready signal, this is also the output signal, indicate the buffer register is empty and Usart can ready to accept the next data byte. Now the transmit enable empty signal, that is the output signal to indicate the output register is empty and Usart is ready to accept the next data byte. Means the new data can be transmitted now, and the data that already exists has been transmitted. Here is the transmit section. Here is the receiver section that accepts the serial data on the received data, this signal, and converts them to parallel data. Because in receiving end, the data will be feed to the microprocessor, and microprocessor is a parallel device. Therefore, it have two registers. One is called receive buffer input register, and second one is called buffer register. So this is the receive buffer register, and this is the input buffer register. So buffer register, here is also three signals. One is called receive clock, receive ready, and receive data. Receive data is the input signal, receive ready is output signal, and receive clock is input signal. So receiver section have received the data bit by bit on the receive data line in the input register, and the rate determined by the receiver clock. The input register converts this serial data into the parallel and transferred to the receive buffer register. When the data byte is transferred from the input register to receive buffer register, the control logic generates a signal receive ready to the processor about the availability of the data byte for read by the processor. Here are some control signals for receiver section. When the receiver data goes low, the control logic assumes that it is the start bit, wait for half a bit time and samples the line again. If the line is still low, the input register accepts the following data and load it into the buffer register at the rate determined by the receiver clock. And the receive ready is output signal that goes high when Usart has a character in the buffer register and ready to transmit it on the microprocessor. Receive ready is a data input signal and bits are received serially on this line and converted into parallel byte in the receiver input register. There is one more signal, that is receive clock input signal. This is the clock signal that controls the rate at which the bits are received by the Usart. Here is one more section that is called modem control. So in the pin diagram of 8251 microcontroller has a set of control input and output that can be used to simplify the interface of almost all modems. Modem control unit allow the interface and to establish the data communication through modem or the telephone lines. This unit take care of handshaking signal for the modem interface. Handshaking signal are the signals that are initiated before the actual transmission of the data. Means there are some negotiation between receiver and the transmitter. So what are these signals? These signals are data set ready. This checks if the data set is ready when the communication with the modem. One is called data terminal ready, indicates that device is ready to accept the data when 8251 is communicating with the modem. One is called request to send. This is low signal, indicate the modem that receive is ready to receive the data bytes from the modem. One is called clear to send. It is a low on this input signal that enable the 8251 to transmit the serial data if transmit enable bit is command by byte to 1. Here is the pin diagram of 8251 that provides all the signals. There are, as we have already discussed in previous diagram, there are total 28 pins in 8251, pin number 1 to pin number 28. So pin number 1 to 5, 6, 7, 8, these are the and 28, 27, these are the signals for data bus, that is bidirectional data bus that receive and transmit the data from microprocessor to 8251 and vice versa. This is the ground signal for grounding, and this is the VCC signal for um, power supply. This is the receive ready signal. Same like this is the receive ready signal, receive data signal, transmit clock signal, write signal, chip select signal, control or data signal, transmit data signal, clock, transmit empty signal. All these signals we have covered in already have been covered in previous diagram of USART. That is, we have already discussed all these signals in this. So for today, we have covered the 8251 USART, that is the um, universal synchronous asynchronous receiver transmitter for serial communication of data, and the need of serial communication we have already discussed in some last lecture, video lecture. So thank you so much. Be take care.